Okay, so we are doing it for the uninterrupted flow facilities. This is as per highway capacity manual. We discussed the definition of capacity as per the manual, but you know the concept is maximum flow rate. Then we looked at ideal capacities. Okay, we discussed the concept of level of service, which tells you about the quality of traffic flow, and they are divided into 6 levels from A to F. Yeah. Okay. So if I want to find out the level of service for the highway or for any traffic facility, I need a number. So I can say that if this number is this much, then the level of service is this much. Same thing as your grades. Okay, if your grade is this much from, let's say, if your grade is 90% above, or your marks are 90% above, the grade is A. If it is between this and this, it is A minor, and so on and so forth. So I need this number. So the number which we use to find out level of service or decide the level of service is called as service measure. Okay, so what is a service measure? It is a traffic parameter which is linked with the level of service. So for most of the uninterrupted flow facilities, which you see in the first row of this table, the service measure is density. So if you know density, in the second row. So the facilities which we are discussing in this course are uninterrupted flow facilities, and for these facilities, the service measure is density. So if you know the density, then you can find out the level of service for most of the uninterrupted flow facilities. For interrupted flow facilities, it is mainly delay. Okay, control delay. Then we have some exceptions here. For example, two-lane highway is an exception for uninterrupted, and urban street is an exception for interrupted. For urban streets, we use average traveler speed, and for uninterrupted two-lane highway, we use percent time spent following, and again average traveler speed. So for two-lane highways, there are two parameters. We will discuss both of them later on with two-lane facilities. Okay, and then there are facilities which are for other road users such as pedestrians, bus passengers, and so on. So they have their own method. Okay, so the method is different. It is written, the method is shown with all the calculation examples in the highway capacity manual, but it is not part of this course. Okay, so you can see here mainly for interrupted it is delay, for uninterrupted it is density, and then we have exceptions where you need average speed and percent time spent following for the highway facilities. Now we will be dealing with density here. Okay, for this lecture you will be dealing with service measure of density. The facilities which we are discussing in these lectures are these two: multi-lane highways and basic freeways. Multi-lane highways and basic freeways. So you can see in both the cases the service measure is density. Now who can tell me the meaning of density? What density means for traffic? We have discussed it earlier. Okay, we discussed earlier in lecture 1 and so on. So what do we mean by density? Traffic density is what? It's a ratio of what? Yes, anyone? How do we calculate traffic density? Yes, anyone? What is meant by traffic density?
Number of vehicles divided by the length.
Yes, number of vehicles divided by the length. Yes, well done. So we'll be using that here. Okay, the density changes according to flow rate. Okay, the density changes according to demand, but demand is something we cannot measure, so we measure the flow rate. So every level of service has a maximum flow rate, and that is called as a service flow rate. Every level of service has a limit of maximum flow rate, that is called as service flow rate. So if I say the service flow rate for A is 1000, so when you go above 1000, your level of service does not remain A. And if you say for B it is 1200, so when you go above 1200, your service flow rate does not, sorry, your level of service does not remain B. Okay, so every level of service has a maximum flow rate, which is called as service flow rate. If you go from A to B up to E, then E is, if you remember, is the capacity condition. So the maximum flow rate at E is actually the capacity of the facility. The maximum service flow rate, or the service flow rate for E, is the capacity of the facility. Okay, so if you find out capacity, that becomes the service flow rate for E. And after E, we enter into F, which doesn't have any limit, like it's as bad as it can get, right? So yeah, the equation which you see here, this is the relationship between volume and flow rate. Okay, volume equals flow rate into peak hour factor. Flow rate into peak hour factor. So if you are taking maximum flow rate, you will get maximum volume. If you are taking service flow rate for A, you will get service volume for A. Okay, so this equation is the basic relationship between volume and flow rate, and whichever flow rate you put, you will get the corresponding volume. If you put the flow rate of capacity, you will get the volume of capacity, and so on and so forth. As I mentioned earlier, in these slides we are discussing two types of highways from the uninterrupted sequence series, basic freeways and Multilane highways. So basic freeways are pure uninterrupted, they don't have intersections, they have a median, they have more than two lanes, they have at least two lanes in each direction, and the difference between one freeway and the other freeways is mainly because of the number of lanes they have. They don't have intersections, but they can have interchanges. Interchanges meaning ramps. So you can use ramps to enter and exit these freeways. Okay, no intersection, so you need something to enter and exit the freeway. So those points have ramps. Then we have multi-lane highways. They again have at least two lanes, but the main difference between them and the freeways is these facilities have intersections, but the intersections must be at least 2 miles for the segment to be called a multi-lane highway, or for the segment to be treated as uninterrupted. So any part of multi-lane highway which you are treating as uninterrupted should have a spacing of 2 miles at least between the intersections. So multi-lane highways have intersections. This is the main difference between them and the freeways. And other differences that it can be with median, without median. With median, we call them divided. Without median, we call them undivided. Okay, so divided is with median, the other one is without median. Okay, and again you have to consider the number of lanes as well. We have at least two in each direction, but it can be more than two as well, obviously. We are discussing them together because highway capacity manual provides the same process for level of service for both of them. Okay, so that's why the procedure is same, but the equations will be different. Okay, the procedure is same. So in both cases, the first item you need is free flow speed. Okay, the speed at low traffic conditions. So this is the first item you need for both of them, or even for two-lane highways, you will see later on. Okay, and we have discussed this in the spot speed case, that if the flow is less than 1000 vehicles per hour per lane, the average speed in those conditions can be considered as free flow. Okay, in both the cases we depend on a graph which is called as a speed flow graph. For multi-lane highways and freeways, we depend upon a graph which is called as a speed flow graph. Okay, in both cases, there are conditions which are considered as ideal. Okay, so these conditions which you see, the last 3 points, are those which are common for both of them. Common for both of them. Later on, we will see some other conditions as well, but they are different for each type. Okay, so these three are common. What is the first base condition? Base means ideal here. The base means best. Okay, both are from B. So base means best. So the first condition is no heavy vehicles. So all vehicles are passenger cars. Passenger cars, you know, they are faster than heavy vehicles and they take less space. Then the drivers are familiar drivers. Okay, the name given to these drivers who are familiar with the highway, who know the highway, is commuters. Okay, so who are commuters? People who regularly travel on any facility. So we have bus commuters, train commuters, highway commuters. Okay, so if I say this guy, the commuter of this highway, that means he regularly travels on this highway. So why is this part of the base condition? Because a familiar driver will make less disturbance. He will go faster as well because he knows the highway. So he will make less lane changes, or he's supposed to make less lane changes. Yeah, there are insane and mad drivers who cannot stick to one lane. Okay, but usually regular drivers, they know which lane to go into and when. So they create less disturbance and they go usually faster because they have more confidence and they know the ways, the directions. So this is the graph which we follow for both these types of highways. Okay, the speed flow graphs, the speed on the y-axis, flow on the x-axis. So you see, I showed something similar in, I forgot now, in lecture 1, I believe. Okay, but that graph which I showed you there was full. This one is only up to capacity. You can see the last point on the curve is capacity. What is this graph showing? It shows you the changes in speed according to the flow rate up to the level of capacity. Okay, so how speed changes when flow rate increases, okay, up to the last point of capacity. You can see the first portion of the graph, the straight line. Okay, in this portion the speed equals to free flow speed. So this condition, speed equals free flow speed. Okay, it's in this portion. How much is this portion? The last point of this straight portion is called the break point, BP. Okay, not blood pressure, break point. Okay, so break point is the last point of this straight line, after which the speed is not equal to free flow speed. Before this, speed is equal to free flow speed. Okay, so this is what they have written here. If I want to find out the speed of the road in this section, then I have to use this big, scary, complex equation. Okay, so we know the meaning of free flow speed. C means capacity of the road. This point. Okay, we have equations to find this point, but I'm talking about this point. So C means capacity. DC is called critical density. DC is called critical density. Now, who remembers the meaning of critical density here? It was in lecture 1. Anybody who started preparing for the exam next week, what is the meaning of critical density? Yes, anybody who remembers the meaning of critical density from lecture 1? You may have an idea about it from this graph as well. This graph is showing you critical density. It's only showing you one density, and this is the one I'm calling as critical density. Anyone? Okay, so that means you need uh, more practice. Okay, but critical density in this case is 45. You need to start to prepare for the exam. Then this is when you will know what is critical density. But in this case, DC is 45. Okay, you need to go and check what is it. But I'm telling you the value in this case, as the graph shows, is 45. Okay, in this equation then you can see BP as well. BP is a breakpoint I told you, and you see VP, this one. Okay, this one. So this is the actual flow rate of the highway, the actual flow rate on the highway, and this flow rate must be more than breakpoint to use this equation. If the flow rate is less than breakpoint, then this equation is not required. You will say speed equals to free flow speed. If flow rate is more than capacity, then this whole graph is not required. Okay, this whole graph is not applicable there. The graph does not show anything beyond capacity. Okay, so flow rate can move from 0 up to capacity, from 0 to breakpoint, speed equals to free flow speed. After breakpoint till capacity, this scary equation. Okay. Now, the things which were written in the equations, the first thing is free flow speed. We know how to measure the free flow speed. We do spot speed studies for that. For freeways, you may have to adjust the free flow speed. You may have to adjust the free flow speed. So that's why you saw in the equation this subscript was there. So this refers to adjusted free flow speed. For multi-lane highways, free flow speed and adjusted free flow speed are equal. For freeways, both of them can be different. Okay, you may have to multiply with some adjustment factors to get the adjusted free flow speed only for freeways. How to get the adjustment factors? It will come later on. Then we have equation for capacity. You are supposed to use capacity here, right? This point. So what is the equation? This is for freeways. This is for multi-lane highways. When will these equations work? In these ranges. So the equations work in these ranges. Okay, if you go out of the range for capacity, you will take the maximum from the range. So for example, the equation gave you capacity of 2500 and it's a freeway. So the range says the capacity cannot be more than 2400. So capacity becomes this value. Okay, anything more than this value will be discarded and you will take this one. But anything less than this, you will take it as it is for both cases. Okay, they have a different range and they have a range for free flow speed as well. If you are dealing with freeways, capacity can also be multiplied with adjustment factors. Okay, and then the adjusted capacity will be put into this equation. If you are dealing with multi-lane highways, then adjusted and simple one is the same. Okay, so for multi-lane highways, no adjustment for speed and no adjustment for capacity. Okay, then we have the equation for breakpoint. Okay, for freeways, breakpoint has an equation. For multi-lane highways, breakpoint has a value. So multi-lane highways, breakpoint doesn't change. Then we have the last values for A. What is this A? You can see A in this equation. We are using it twice here as the power. Okay, so there are fixed values for A for each case, for multi-lane highways and freeways. Okay, so for example, if this thing is given here, then you are required to calculate capacity, breakpoint and speed. Okay, so three things: capacity, breakpoint and this. So for example, if I take the first case, I will start with capacity and breakpoint. So if I come here, the equation for capacity is this. I need free flow speed. Okay, so free flow speed is 65. So capacity is, as per the equation 2200 plus 10 into 65 minus 50. Okay, this will give you capacity. Then you need breakpoint. Breakpoint is this one. Okay, now you can see that I'm not using adjustment factors here, although it's a freeway. I'm not using adjustment factors because we haven't studied them. So once we study, we will know when do we actually need to use them. Okay, so with these values, what is the capacity and breakpoint here? Okay, and the breakpoint? Okay. Now to find out the speed, I need to see which condition applies. Now see, I can use this one or this one. Okay, so if I look at the flow rate is 1500. Your breakpoint is 1400. So Vp is more than the breakpoint. Okay, so that means I have to use this equation now. This one. Okay, so free flow speed is 65, capacity 2350, critical density 45, and the value of A is 2 here. Okay, A is 2. How much is the speed here? Tell me. Yes. How much is the speed here? Okay, so I hope it was clear. Let me take one more example for Multilane highway. Okay, so again the same things are given. I'll start with capacity for Multilane highway. This is the capacity. Free flow speed is given as 55. Flow rate is 1200. Okay, so Multilane highway capacity. I'm using this equation now. Third column 1900 20, free flow speed 55, 45. This will give you capacity. Okay, breakpoint 1400, doesn't change. Okay, passenger car per hour per lane. Okay, the units are passenger car per hour per lane. Even the flow rate is also passenger car per hour per lane. If it is not in these units, you need to convert it, and I will show you how to convert it. Okay, so if I look at the flow rate here, flow rate is less than breakpoint. That means speed equals to free flow speed. Okay, so that means it is 55 miles per hour. Okay, so you can go ahead and do the third example as well. It's about a freeway. Any questions? Okay. Now in these speed flow curves, you can draw the surface measure, the density, as diagonal lines, because density is flow rate upon speed. Density is flow rate upon speed. Okay, so if you know density, then you know the slope. Okay, flow rate upon speed will become the slope, right? So these values are basically the slope of these lines. Okay, these values are the slope of these lines, the tangent theta. Okay, all of them, they are flow upon speed values. From where do I get these values? It should have come first actually, from here. So every level of service has a range of density. So you can see the first one has 0 to 11, then after 11 to 18, then to 26, and 35 and 45. So these are used as slopes here. Okay, so they plotted these curves. Okay, I will show you with an example later on how the curves are plotted, and you have to do it for your term project as well. So but it starts with free flow speed, it reaches to breakpoint, and then it goes down up to capacity. Once the curve is plotted, then you can go to this table, take these values, the maximum values, as the slope of the lines, and then you come back and you plot these. Okay, so this one is plotted using the equations of Freeways, and the next one is plotted using the equation of multi-lane highways. Okay, because both of them have different equations, so we cannot use the same curves. Okay, so in all the cases you can see the shape of all the graphs is the same, straight line up to breakpoint, then goes down. Okay, so whether they are these curves or these, the shape is the same, the points are changing. Obviously this, the capacity is lower, this capacity is higher. Okay, you can see the breakpoint is changing. This one has breakpoint up till here, this one has breakpoint up till here. The values are changing, but if you look at the shape is same. Okay, so if for example somebody told you that or if you take this example, let's say, so free flow speed 65, flow rate 1500. Okay, you see 65 here. Okay, now flow rate 1500 is here. Okay, so if I go to this curve 65, I know the level of service. So this is the use of plotting these lines. Once the curve is plotted, the lines are plotted, then you can easily find out the level of service without further calculations if you know the flow rate and the free flow speed. Okay, so if I take the example of multi-lane highway, free flow speed 55, flow rate 1200. 55 is here, this line, this curve. Okay, 1200 is here. Okay, so we come to the curve, I know my level of service is C. Okay, if you have this, then you can do it in this manner. Otherwise we have calculations to find out the level of service as well. So this is another method, but to use this method the curve must already be plotted and these lines must be intersecting as well. If you are missing something, you cannot find out level of service like this. Okay, so I showed you this. Yeah, this is another way of finding out the level of service, which is for using the volume upon capacity ratio. So in this method they are using or finding out level of service only using density. Here they are using V by C ratio, volume upon capacity ratio. Okay, so this is for a highway which has 70 miles per hour speed. This is for 60 miles per hour. This is for 50 miles per hour. So in the old manuals, this one was given, and some of the highway agencies are still using it because it is very easy. They already know the capacity because they designed the road, and they just find out the flow rate from the highway, and they just do the ratio, and they know the level of service. So it becomes very easy. Okay, no need to find out free flow speed and everything. Okay, so if you are looking at these values, Okay, then this is the curve. These curves represent these values. If you are going by the old manuals, okay, then this is how the curve will look like. The speed flow curve will look like. Obviously capacity is constant, right? Capacity is constant. So when you take flow upon capacity ratio, you are dividing different flows upon capacity. So flow is increasing. It was 0, increase, increase, increase. It went up to 1. Flow upon capacity became 1. That means flow equals to capacity. Okay, and this is how these values can be plotted. We'll not go in detail because this method is only used for convenience. So there's whatever the calculation was behind it, it was in the old manual. Now they are not using it. Okay, yes. Okay, so I told you about service flow rate just now. What is the meaning of service flow rate? Remind me. How did we define service flow rate? Yes, anyone? The meaning of service flow rate. I told you now, today, in this lecture. Maximum flow rate, huh? No, so why do we call it service flow rate? Why is the word service used with it? Yes, the maximum for the level of service. Okay. So how do I find out the maximum flow rate for level of service? Again, you go back to these graphs. So you plot the graph, then you use the maximum density values from the highway capacity manual or each level of service and plot these lines using the densities as their slope. So now you can see when I am beyond this line, my level of service changes from A to B. When I cross this diagonal line, my level of service changes from A to B. So the flow at which this line intersects becomes my service flow rate for A. Okay, at this line I have the maximum service flow rate of A. Okay, so at this point I will have it for free flow speed of 45. At this point I will have it for free flow speed of 50 and so on. If I want it for B, so let's say service flow rate for B for free flow speed of 60. So I have the line for B here using its density and the free flow speed of 60 is here. So this is my service flow rate for B. Okay, so for these graphs, this is for freeways again and this is for multi highways. So the 55 service flow rates for freeways are different. The free flow speed 55 miles per hour has different service flow rate for as a freeway and different one as a multi and highway. Okay, so the values are not same. So you see two tables here, one for freeways and one for multi and highways. Okay, and this is how they are coming. So if I focus on this value, free flow speed 75, level of service B, let's say. Okay, so I come here, free flow speed 75, level of service B, this line. So if I go this intersection point, I go to the x-axis and find out what is the service flow rate here. Okay, so the service flow rate is where the line intersects the speed flow curve. Okay, so these values are taken for these graphs, these curves, and they are given to you here as examples. Any questions? Any questions? Any problems? Okay, so I'll take it as no problem. Moving on. we have seen here that speed and capacity for basic freeway may need adjustment factors. So now let us talk about these adjustment factors. So we are talking about adjustment factors for speed and capacity which are applied to freeways. Multi-lane highways do not have these things. Adjustment factors are applied when any condition, any special condition is faced in the field for long times. Okay, so normal conditions are you have good weather just like Bahrain, alhamdulillah. You have no traffic incidents or accidents, inshallah. You have no work zones, okay, could be, and you have motorists and drivers who are familiar with the facility, mashallah, right? So we have all these things here. So if you meet all these things, good weather, no traffic incidents or accidents, no work zones, and motorists and drivers are regular users, they are commuters of this highway you are analyzing. So these are your best conditions. If you meet them, adjustment factors are out of the question. Okay, so if you meet all these four conditions, speed and free flow speed, free flow speed and capacity remain same, no adjustment. Okay, so we are talking about only freeways. Now we are saying even in freeways you don't have to apply the adjustment factors always. You only apply the adjustment factor when and if one of these conditions not met. Okay, so which condition affects what? Some conditions affect capacity, some conditions affect speed, some of them affect both. Okay, so this table gives you what is affecting what. So weather affects capacity and speed both. Incident only affects capacity. Dark population only affects both, and work zone also affects both. Okay, so you have only incidents which only affect capacity, the rest of them affect both the parameters. Okay, so what if I have condition not meeting the weather and condition not meeting the work zone? Okay, work zone meaning construction or maintenance activity. Work zone means construction or maintenance activity. Now you can see here, if I have weather problem and I have work zone problem, then weather will have adjustment for capacity and adjustment for speed, and work zone will also have adjustment for capacity and adjustment for speed. So for capacity I will have two adjustment factors, for speed I will have two adjustment factors. Okay, I need to combine them, combine the two for capacity and combine the two for speed. Okay, how do you combine them? You multiply. So in a particular case, if all four conditions require adjustment, then you will have four factors multiplied with together, and in the end it becomes one factor. Okay, same thing for speed. Speed can only have up to three factors because incident has no effect on the speed. So if you have in some condition all three factors, then all three of them will be multiplied together to make it into one factor. Okay, so you may have more than one adjustment condition, but in the end you will multiply. Okay, then after multiplying, whatever factor you will get, you will multiply them with the parameter to get the adjusted value. So I multiply all the adjustment factors into one, and then that one factor is multiplied by the speed. Same thing for capacity. Okay, okay, so this table shows you adjustment factor of weather which is applied to capacity of freeways. So you have the weather conditions, you have the meaning, the description of the weather, and you have the free flow speed. Okay, so you will get the weather condition from here and you will multiply with the capacity. This one is for speed, weather condition, speed, same thing. This one is for incidents, so only for capacity, no speed. And here you can see it depends upon number of lanes and depends upon what is closed from these lanes. Okay, so if only shoulder is closed because of the incident, this one lane is closed, this one, two lanes are closed, this one, so on and so forth. And you can see here, if two lanes are closed, there is no factor. Okay, it means what? I have two lanes and two are closed. Obviously 3 cannot be closed and 4 cannot be closed because I have only two lanes. So if two lanes are there and incident closed both of them, that means no flow at all. Okay, the capacity becomes 0 because you have closed both the lanes. Okay, so these values which are written as NA, not available or not applicable, whatever you want to read it, it means that either these many lanes cannot be closed, for example 3 cannot be closed in two lanes, or it means that when you close these lanes the highway has completely become closed. So two lanes and both of them closed, highway is closed. This is for driver familiarity. Okay, if all drivers are familiar, adjustment factors are 1. Most of them are familiar. You have equal, familiar, unfamiliar. You have most of them unfamiliar and all of them unfamiliar. And then these are the factors. Okay. For work zone, this is where we need to do some calculations. So pay attention now. Later on, we will do an example as well. So if you want to calculate adjustment factor for capacity because of work zone, you have to use this equation. In this equation you can see two factors, W and QDR. W is called the decrease in capacity because of the work zone, and QDR is called Q discharge rate. Okay, so QDR is Q discharge rate, and alpha is the reduction in capacity of the highway because of work zone. Now you can see for QDR we have a long equation here. Okay, and this equation has how many? 1 2 3 4 5 factors. Okay, so I need to find out how these factors are taken. So the first factor is called as lane closure severity index, LCSI, lane closure severity index. From where do I get lane closure severity index? This table. So you need normal lanes, you have open lanes with the work zone, and then you can get LCSI. Don't worry about this ratio, we are not using it. So if you know the normal lanes without the work zone, how many of them are still open with the work zone, and then you can get the required factor here. Now if I have 3 lanes which are which were open in normal case, because of the work zone I still have 3 lanes. So there was 3 lanes before, still 3 lanes. So what is the effect of work zone? Where is the effect of work zone here? Tell me. If the work zone did not close any lane, why should I consider the effect of work zone? You can see 2 and 2 as well. Okay, there can be 4 and 2, I don't know. But you can see 2 open normal and 2 open work zone. So if the work zone is not closing any lane, why am I considering the effect of the work zone? What could be the reason? Yes, anyone? Do you know if the work zone does not close any lane, then why should I consider it? We are considering it, like it's not like we should or not. I'm asking why are you considering it? It's not about whether we are doing it or not. We are doing it. Okay, even if the work zone is not closing any lane, we are taking the factor for it. But the question is why? Anyone? No one? No one has any answer? Okay, no problem. But you can see the factors, right? I'm not going to uh, feed you the answer because I didn't get anything here. But anyways, you can see the factors are there. Okay, so for the first factor comes from this table. The second factor is for barrier type. Okay, barrier type means what? Whenever you have a work zone, between the work zone and the road, the remaining road, you have to put a barrier. It's part of the safety regulations. So if the barrier which you are putting between the work zone and the road is made up of concrete, then FBR becomes 0, otherwise FBR is 1. Then we have the factor for area type. Area is divided into two categories, urban and rural. If your highway is in the urban area, the factor is 0. In the rural area, it becomes 1. Then we have the lateral clearance, which is the distance between the barrier and the road. So you may have the barrier and then some distance and then the lane. Okay, so there could be some distance between the barrier and the lane. So that distance is FLAT, this one. So there is a distance between the barrier and the lane. And then we have the factor for day and night. If your analysis period is day, then this factor is 0. If your analysis period is night, then this factor is 1. Okay, so you find out QDR from here and then you put it in this equation to get capacity of the work zone. Okay, so this will give you capacity of the work zone. If you want the adjustment factor of the work zone, so capacity of the work zone divided by the original capacity, the capacity which we calculated in this example using the equation. Okay, so in these examples we calculate the capacity using these equations, right? So these equations give you normal capacity without the work zone. Okay, so if you want adjustment factor of the work zone, you take the ratio. CWZ comes from here and C will come from that equation. So the ratio will give you adjustment factor of capacity for the work zone. Then if you want adjustment factor of speed for the work zone, you'll calculate the free flow speed of the work zone. Okay, so this is the equation to calculate free flow speed of the work zone. You have the speed ratio. Okay, what is the speed ratio? Speed limit without the work zone upon speed limit with the work zone. Okay, FSR is a ratio, speed limit without work zone, speed limit with work zone. So this is speed limit with the work zone. Then you have LCSI, which is from this table. Then you have factor for barrier type, I already explained here. And then you have factor for day and night, same thing as this one. And then you have factor, not a factor, this is called as total ramp density. TRD means total ramp density. Okay, what is the meaning or how do we calculate total ramp density? Let's say I'm doing the analysis here in this segment. Okay, so from this segment I go 3 miles forward and I go 3 miles back as well. So 3 miles in each direction, the total will be 6 miles. Okay, and you count how many ramps you have. Okay, so for example I can count here there are 4 ramps. Okay, so TRD will be 4 upon 6. If you got 5 rem, it will be 5 upon 6. You got 10 rems, it will be 10 upon 6. Okay, so the distance is always 6. Okay, so this 3 mile forward and 3 mile backward is constant. So total will always be 6. Okay, and then you have to count the number of rems. Whatever you get, you will divide by 6. Okay, once you find out the free flow speed in the work zone, like we did for capacity, we'll take the ratio. So free flow speed of the work zone from this equation, and free flow speed from the highway itself. Okay, you can do the spot speed study for that. Okay, let us look at an example. We have a long-term work zone on a freeway. Okay, now if there is a work zone which only happens for 2 days, so there's some small maintenance work going on, within 2 days it will be finished. So for these 2 days I will not calculate the adjusted capacity and speed and so on, because the rest of the 300 odd days the highway is at normal capacity. There is no effect of the work zone. So I will consider the case which happens frequently during the year. Okay, not the odd exceptional case. Same thing with the weather. Okay, the weather condition, if most of the times the weather is good, okay, so few days of rain will not require the adjustment factors and the new speed and capacity and so on. Okay, so adjustment factors are only done when the condition is long term. Okay, the condition is persistent, it is frequent, it happens most of the times of the year. So maybe the weather condition in Canada or in Malaysia or those countries where they have snowfall and rain for much of the year, they can use the adjustment factors for weather. But if you have few days of rain like we have in Bahrain, we will not go for a new factor in that case. Okay, the highway has 8 lanes. 2 of these 8 lanes are closed, okay, due to major maintenance operation. So it's a long-term work which is doing major maintenance. Out of 8, 2 lanes are closed. The free flow speed outside the work zone is given. Work zone has a barrier of concrete. It is 0 feet from the lane. The barrier and the lane is at the same point. So barrier is at the edge of the lane. Barrier is at the edge of the lane. It's in a rural area. The critical operation is during the day. Speed limit for the work zone is 45. Outside the work zone it is 70. Total ram density 3 rams per mile. You have to find out the capacity and speed, free flow speed of the work zone, and then find out adjustment factors for the work zone. Okay, so you start with the capacity of the work zone. So this one, alpha is fixed 13.4%. okay, according to the manual they are using this. QDR we have to find out. Okay, so QDR has this equation. Okay, the first one is SCSI. Okay, so I need to use this table now. Now each direction has 4 lanes. Each direction has 4 lanes. Okay, out of the 4, 3 are closed because 2 out of 8, right? They have written 2 out of 8 are closed. So 3 out of 4, okay, in each direction. So 4 lanes and 3 are closed. Okay, so my SCSI is 40.44. Then the next one is for barrier type. I'm using concrete barrier, so it becomes 0. The next factor is for area type. Area is rural, so I have a factor of 1 here. The next factor is for the lateral distance between the barrier and the work zone, which was 0. So distance is 0. You're multiplying with 0, so The next one is for day and night condition. The critical period is during daytime. Okay, so this again becomes 0. So how much is my QDR here? Okay, so capacity of the work zone is this value. Okay, how much is this? Okay, so this is the capacity of the work zone. Now I'll calculate the speed of the work zone, which is from this equation. Okay, so I need the FSR ratio here. Okay, so how much is this ratio? It was normal. Okay, normal speed limit is 70, work zone speed limit is 45. How much is this? Okay, so now we can find out the free flow speed of the work zone. So 9.95, 33.49 into the factor 0.53 free flow, sorry, speed limit of the work zone 45 minus 5.60. LCSI is the same which I used in the previous calculation, 3.84. The factor for barrier type was 0, remember, concrete barrier, so this becomes 0. Then factor for day and night, again for daytime it was 0, so again it is 0. Then the last one is total ramp density, which is given as 3 ramps per mile. Okay, so 8.7 into 3. How much is this? Okay, so now we have the free flow speed of the work zone and the capacity of the work zone. If I want the adjustment factors, I need the normal capacity as well. It's a freeway. Normal capacity is free flow speed, which is 70. Let me just check. Yeah. Okay, how much is the normal capacity? Okay, so this is the normal capacity, and if you want the adjustment factor for capacity, it will be the capacity with the work zone, which is this one, 2132, upon normal capacity, which is this one. So how much is this? No, the capacity with the work zone, how much is this? 2200 plus 10 into 20. Yes, 2400. Yes. Mariam did not multiply by 10. So 2400 is the correct answer. Okay, if you want the speed adjustment factor for the work zone, you will take the speed with the work zone, which is 57.5 or 48, whatever you want to take, and upon 70, the normal free flow speed, it is given in the question. So how much is this? Okay, so you have the adjustment factors because of the work zone in both cases. Okay, so is this clear? Any questions? Okay, so okay, I told you whenever you have analysis like this, you can we should start with the free flow speed. Now, if the free flow speed is given, you did the spot speed study, or somebody did the spot speed study, they gave you the free flow speed, it's fine. But let's say you did not get a chance to do the spot speed study in the field, so free flow speed is not available. Free flow speed from the field is not available, so I have to do some calculations to find out the free flow speed. For these calculations, I need these parameters, these extra values I need to find from the field. If free flow speed is not available from the field, then you need to calculate, and then you need these values, otherwise we don't need them for the calculations. So we need lane width, we need lateral clearance. What do we mean by lateral clearance? The distance between the lane and any roadside object, the distance between the lane and any other object beside the road, that is called as lateral clearance. Okay, so if after the lane you have a shoulder, and after the shoulder you have a barrier. Okay, so let's say the shoulder is 4 feet and then you have the barrier, so lateral clearance becomes 4 feet. Okay, because the barrier is directly after the shoulder. Okay, so any clear space is part of the lateral clearance. The type of median, now for freeways, I told you freeways have a median. You cannot have a freeway without a median, it is against the safety standards. So the only highway in which we will need median for free flow speed is Multilane highways. Okay, so I told you with median we call them divided, without median we call them undivided. Then we have frequency of ramps or frequency of access points. I already explained to you the term TRD, so you need TRD for freeways. Okay, so you need TRD for freeways if you are calculating the adjustment factor, and you also need TRD for freeways if you are calculating the free flow speed. It's the same TRD, total ramp density is the same way. 3 mile forward, backward, count the ramps, divide by 6. So it remains the same for both cases, but you only need it for freeways. Because freeways don't have intersections, so they only have ramps. But what about multi-lane highways? Multi-lane highways have access points. Okay, and remember, the portion, the segment of multi-lane highway which we consider as uninterrupted, that is between two intersections. Okay, so intersections are at the ends. Intersections are not part of the segment. Now within this segment, we are not counting the intersection. Intersection comes, the uninterrupted thing is gone. Okay, so we are talking about between the intersections. Between the intersections, you may have access points. What is an access point? It is at grade entry and exit to the highway. Okay, so you may have a highway. So this is a highway. Okay, and at this point you have this point over here. Okay, so people can go in and they can come out. This is called an access point. Okay, it doesn't have a left turn and doesn't have any signal or something. Okay, so access point is for entry and exit, right entry and exit, and in Bahrain they call them right in, right out. Okay, So they are not ramps. You are not going up and down at the same level at grade. And this only for right. So you can go in right and come out right. No left turn. And this is without any signals. No signals. Okay. So this is called an access point. And it is not an intersection. Okay. So you count number of access point and divide by the length of the multi segment. Okay, segment. I'm not saying the highway. Segment. Okay. Then percentage of heavy vehicles in the traffic, and you also need driver population factor. Okay. So if you want to find out the free flow speed and level of service, you may need these things. Okay. So this is the data which you should take from the highway, especially if free flow speed is not known. Okay, so what to do with the data? You have to put it in these equations. So this equation gives you free flow speed for the freeways. Okay, so there are three factors here. TRD I already explained, total ramp density, and then you have factor for lane width, FLW. Where to get the factor? You can see the table at the bottom. Okay, just put the value of the lane width and get the factor. The next factor is lateral clearance. Lateral clearance will come from this table. Okay, so how much lateral clearance you have on the right hand side? Okay, the shoulder side, the whatever you call it. Okay, right hand side, and how many lanes you have in one direction. Okay, so value of the clearance and the number of lanes in one direction, you get the factor from here. You put these two factors with total ramp density here, you can calculate the free flow speed. Okay, but we prefer field value. Spot speed study is preferred for the free flow speed, not the equation. This equation is for multi-lane highway. This equation is for multi-lane. So you can see the equations are different. So BFFS means base free flow speed. Base free flow speed is the maximum design speed for the road. Okay, as per standard. As per standard. Factor for lane width, FLW, same. This one. Same which we are using for freeways. Then we have factor for lateral clearance. This one. What's the difference between this and the previous one? There we were using lateral clearance on the right hand side. Here we are using lateral clearance total. Okay. Total means right plus left. So on the right hand side 2 feet, left hand side 4 feet, 2 plus 4, 6. So you will use 6 here. Okay, and again you need the number of lanes as well. Then we have two more factors. One for median type. So I told you can have divided and undivided highway. The other one, the next one is for access point. I already explained. Right in, right out without signals. Okay, you count them, divide by the length. So this will give you access point density, and you take the factor from here. So you have 4 factors. Okay, lane width, lateral clearance, median type, access point density. You put these 4 factors with the base free flow speed, and you get the free flow speed of the road. Now a couple of things here. First thing is we have 3 median types here. We know undivided means without median. We know divided means with median. What is the meaning of two-way left turn lane? TW LTL is two-way left turn lane. It's an extra odd lane in the middle. Extra odd lane in the middle, which is used for left turning only. Okay, so you have let's say 2 lanes here, you have 2 lanes here. So this one is your extra lane which you can use for left turning, and the lane is continuous. So even the guy, if there's a left turn here, even this guy can use the middle lane. Okay, so it's an extra middle lane which you can use for turning left. So if you want to turn left, you will wait for your turn in this extra lane. You will not stop any traffic. Okay, so no signals and nothing required here for left turning. So it's a smart way of dealing with the left turning. Okay, so this is one. Second thing is if you have undivided road. Undivided means there between one direction and the other direction there is no separation, nothing. Okay, so you have this highway. So this is the end of one direction, this is This is a line, just a line, nothing, no median, no barrier, nothing. Okay, this is going and this one is coming. Between them I just have a line, I just marking. Okay, so this is undivided. What is the lateral clearance here? The lateral clearance here is 0. Okay, because from this direction, after 0 feet I have the other direction. From this direction I have 0 feet for the other direction. So on the left hand side the lateral clearance is 0. But for why it is 0? Because the highway is undivided. Okay, so undivided highway has left hand side lateral clearance 0. But if I keep it 0, then I'm using the effect of undivided road on lateral clearance, and then I'm using it again for median type. So undivided road is affecting two adjustment factors, the lateral clearance factor as well as the median type factor. I want to avoid this duplication. I want to just use it once. Okay, so how to do it? If the highway is undivided, I'll take factor 1.6 from here for median type. For lateral clearance factor, I'll assume that the left hand side lateral clearance is actually 6 feet full. Okay, 6 feet is considered ideal. So for example, you have undivided highway. On the right hand side, you have lateral clearance 2 feet. On the left hand side, you have 0 because it's undivided. So, but the lateral clearance you will take for this table will be 2 plus 6. 6 is assumed. Okay, so for undivided highways, left hand side lateral clearance becomes 6. Okay, undivided highway, left hand side lateral clearance becomes 6. So this 6 is added to whatever you have on the right hand side. Okay, these are two examples here. Do you have any questions? I will not do the examples now. I'll do it next time. Any questions?